All right, so welcome to the Chem Lab Division C workshop series. So I'm Jason, a neuroscience major at Georgia Tech, and I'm excited to present to everyone the Chem Lab series today. So just a quick rundown of what we're going to cover. We're going to take a look at the rule sheet. We're going to take a look at some essential things that we should all know before entering the exam, and also some difficult topics as well. And after that, we'll take a look at some common questions that might be tested. And then at the end, we'll save some time for the Q&A. Okay. And if anyone has any questions along the way, believe you can use the chat as well. Okay. So go ahead and get started. Okay. All right. So this is the rule sheet. And so we should have all seen this already before. But there's one thing that I do want to mention. It's that with the topics that they write on this rule sheet, many times when we go into regionals or states, right, they can expand beyond this. So as you know, for example, with the stoichiometry, right, they might also include topics with stoichiometry as well. And so it stretches usually beyond, right, just mole conversions or just percent yield, right? So we'll take a look at that in a moment as well. So now let's go ahead and first look at some of the things that we should know before entering the test site. Okay. So starting off, we have the basics, right? And so we need to know how to name compounds, acids, bases, including with polyatomics. Now, many times, right, students do put the polyatomics sheet on their reference sheet, right, on the reference crib sheet kind of that you can bring into the exam, right? But if you have those memorized, right, you can save space for other topics that we're going to talk about in a moment. Another thing is that you should know how to perform calculations, right, regarding Avogadro's rule and stoichiometry. Now, here's the thing, right? We need to know how to do stoichiometry with gases, right, with acids and bases, right, and with thermochemistry, also with electrochemistry, possibly, right, because that relates to the redox, which is also in this year's content. So you see that with stoichiometry, right, it doesn't have to be just a simple problem that they give you with empirical formulas, right, or multiple conversions. It can be with gases. And so you do want to know those formulas as well. Okay. And then also the charges and valence electrons of ions, right? So you want to be familiar with those. Hopefully we all know them. And on most tests, they do give you a formula sheet and, periodic table. Sometimes they might give you a formula sheet, but you shouldn't expect that they will, okay? But in most cases, they'll have a formula sheet on a projector, or they'll have a periodic table on the test, okay? So the periodic table is usually given, but the formula sheet, it really depends on the vet that you're going to. All right. And so as I mentioned here, right, you do want to expect these regionals and state competitions to include extensions of topics, right? So you might have periodic properties of compounds, periodic trends, VSEPR, molecular structure, and bonding theory, right? Because that's all part of right, these essential tools to chemistry, right? You can see here at the bottom, I put an image on like nomenclature, formula writing, and stoichiometry, right? But they can definitely easily tie it into these other topics as well, especially when you get into regionals or states. So you do want to prepare yourself for that. But for most of these topics, they do cover it in AP chemistry. If you're taking honors chemistry, then you might want to learn a little bit more with VSEPR or with periodic trends as well. And so here, you're welcome to take a picture of it, right? These are just some resources I've compiled to help you to right, name these compounds. Hopefully, we all know how to name these compounds by now, right? But if you need a reminder during the exam, you can still utilize this flowchart to help you. Okay. And here's some other resources too, right? The mole map, right? Conversions, right? Percent yield, right? And with these valence electrons. Okay. So the second major topic that we want to take a look at is equilibrium. Okay, so besides from stoichiometry and basic nomenclature, right, equilibrium is the other major topic that's on this year's exam, right? We have to understand the Le Chatelier's principle and predict reactions, right? So that includes, right, knowing, okay, if I ever add a reactant, if I add a product, if I remove a reactant, if I remove a product, if I increase or decrease pressure, right? If I add a catalyst, if I increase or decrease the temperature, depending on if it's an exo or endothermic reaction, right? Those can affect the reaction in a different way, because it wants to reestablish equilibrium, right? So you want to know about, right, why this happens along with what happens, right? So you want to be aware of that, and you want to be familiar with it as well. Okay, right. You also want to be familiar with K, KB, pKa, and pKb, right? So we should all know that, right? It helps to determine how acidic something is, how basic something is, but also, right, doing calculations with those values, right? So you can see here on the bottom left, we have a formula sheet here, and that's essential, right, to performing these calculations. So this is pretty useful in terms of, right, using these values to find the pH, right, converting, using logs, right, stuff like that as well. And on top, right, you have calculations with equilibrium, right, equilibrium constants, and so those are all very useful that you should keep in the back of your mind. Okay, so you should either have this memorized or you should have it on your formula sheet. Prepare to perform a titration, right? So titrations are the easiest experiments out there, right? It's easier to set up for the test writers, right? Especially, if you're a high school setting, right? If you're going to compete in a high school, with universities, right? So like Georgia Tech, they could provide you with a different experiment because they have more resources to do so. Same as GSU when they got regionals, right? You might perform something other than a titration. But with these high school labs, if they even have a laboratory portion, then you will most likely perform some sort of titration, right? Because again, it's just really easy to do, and it doesn't require many resources, right? Okay. And using those titration curves, right, you should be able to perform calculations, right? And so that includes, right, buffers, right? That includes, right, weak bases, strong acids, and vice versa, right? Doing calculations with that. And you can see here, right, we have this titration curve. You should be familiar with that. And also, you should be familiar with the diproduct or polyproduct reactions too, right? Where we see that we have multiple equivalence points, right? We have multiple equivalence points. So you should be familiar with that too, although you most likely won't be doing an experiment with that. That would take a little long. And also lastly, right, understanding your standard absorption curves and calorimeters, right? So I kind of put one here at your absorption curve, absorptions on the y-axis and concentrations on the x-axis. You should be able to interpret these curves and what they mean. Okay. And lastly, right, expect that regional state compensations include extensions of these concepts, right? As I said, buffers, right? You'll definitely see them. In most cases, you won't just have a strong acid and strong base titration. Also stuff like, Gibbs free energy constants, right? That relates to this as well. and equilibrium concepts of organic compounds, right? And I'll introduce that in just a moment as well. I believe in a moment we'll talk about that. But equilibrium of organic compounds, separating organic compounds, and you can see on the bottom for number 6 right there, you see in Roman numerals right there, right? Stand nationals, right? Knowledge and application of equilibrium to separate compounds may be included, right? And for sure, they will put that on the exam, right? Because it helps to really test if you know your material. Okay, so you make sure that in a moment I'll talk about this, but right, expect these extensions of topics. Right. Again, you're welcome to take a picture of all of this, right? Take a picture, maybe put it on your study list or something like that. Your reference sheet as well. And then our last major topic, right, is reactions. And this is, although there's only 3 bullet points, this can be tested very, very heavily. So reaction types, there's a lot of reactions: synthesis, decomposition, single replacement, double replacement, right? Those are the basic ones that we have probably learned since 8th grade, right? Just knowing these general reactions, but we also have, right, combustion, oxidation reduction, acid-base reactions as well, right? So these are the more difficult reactions in which they'll ask you to balance, right? And we'll take a look at them in just a moment. But balance these reactions, right? Identifying them is not too difficult, but balancing them is just take some practice, right? Especially with the redox reactions, finding the ionic equations. Okay. So with that, right, you can see with the 3rd bullet point, I have writing out equations. So you definitely want to know how to write out the equations for oxidation and reduction reactions. Okay. And you should know your solubility rules, right? So you should be aware of your solubility rules as well. Okay. Knowing that is important when we want to determine our night ionics, right? So knowing that is very important. So again, right here I have a list of all of the reactions. Okay. So we have on the top left, right, general reactions that you want to know. On bottom left, we have how you get from a acid-base reaction, right, or general equation to the ionic equation, right? We see that. It shows you the steps, right? But for sure, you're going to need to know your solubility rules, right? In the top right, we see that's an oxidation reaction, right? So you want to know how to balance these reactions, and we'll talk about this. This will be a key focus, and you should know how to balance them in acidic and basic solutions. And then in the middle here, right, I kind of put a list of all the solubility rules that you should know. Okay, so make sure to know the solubility rules. Okay. And then sometimes it's confused with the metathesis reactions. These are just, your kind of your double replacement reactions, right? So knowing what they are and how they can give off precipitates, right? So you might have to do an experiment where you have to produce a precipitate, right? And that is possible too, right? You're going to have to do that. So just keep a lookout on that. Might be a potential, right, lab procedure that you're going to have to do. Right. And then just lastly, right, your lab materials list. And so you should have all these materials, right? But I know that a lot of us don't have all these materials, and that is okay, right? There are certain times where like you don't need 100 milliliter versus a 250 milliliter beaker, right? Especially if you're short on budget, that's okay, right? But you do want a smaller pool of smaller unit of measure, like a 10 milliliter one, and you want something that's usually a little bit larger, like 250 or something like that. just so that it's easier when you do the experiments, right? Because you are on a time crunch. Okay. But besides from that, you definitely, besides from those tools, you definitely should have the Petri dishes. You should have the pH papers for sure. Right. Battery. You might have to do and this year they might give you something with the redox and let you do some experiment with electrochemistry. So that is possible. So we keep on the lookout with that. Because redox is, as I said, a topic this year on the exam. So they could give you something related to that as well. Okay. So big picture, try to have all of these tools, okay, marked in X's. But if you don't, right, you do want to try, and especially with the measuring volumes and doing reactions tools, right, like the beakers and the Erlenmeyer flasks, try and have one that measures small volumes and one that measures usually larger volumes. All right, so now let's jump into the difficult topics. So with all of these that I mentioned, these everyone by now should have some degree of familiarity with them. All right. But now we want to take a look at the difficult topics, and that's where we get into redox, right? So balancing these is really tricky. It's really similar to kind of doing math, right? If you make one mistake, you mess up your entire equation. So you do want to be careful with this. And with balancing redox and acidic solutions, right, you still start off with identifying your oxidation and your reduction reactions. What's being oxidized, what's being reduced, right? And then you can see all of the steps here, and I tried to group them together, right? Along the way here as well in pairs, right, of two. So they're all grouped together, and you can see, right, add oxygen with the third step, right? Add hydrogen with the fourth step, add electrons, and balance them, right? Multiply by 2 and 3 respectively, and then cancel, right? And form H2O. But so the main thing is that, right, you want to make sure you know these steps, right? You understand how to balance redox in acidic solutions. Okay. And so again, right, you need to understand what something being oxidized mean, what does something being reduced mean, and then work yourself from there. There are a lot of practices with redox. And so especially with acidic and basic solutions, they can be a little tricky. Now, I do want to point out a difference between acidic and basic solutions, right? When they tell you on the exam, because it's really tricky, right? People get tricked by this all the time because they don't read the instructions. So remember, whenever we have a basic solution, there's about 3 extra steps on top of what we needed to do with acidic solutions. So remember that we need to add, after we've added the hydrogens, right, hydrogen ions, right, we then also need to add the same corresponding hydroxide ions on both sides, on both equations too, right? So we have to add hydroxides, and those hydroxides and hydrogen ions form water, right? So that's another key characteristic of redox in basic solutions, okay? And then you can then cancel out like terms. So what the difference is, I put a exclamation point by, right, the corresponding steps, so you can take note of that, okay? This is pretty useful if you want to put it on your cheat sheet. You kind of want to condense it, maybe just, it can be a useful tool as well, knowing what to do. It's really, doing these problems are really procedural, right? You kind of realize by now that, right, it just takes a lot of procedure, just a lot of practice with doing this. So just make sure that you get in some good practice with this, okay? Right. Topic 2 that we want to talk about is compound separation, right? So as I mentioned earlier, how I said that with equilibrium, right, they can include topics with using equilibrium to separate chemicals may be included, right? So separation of chemicals, that relates to First, chromatography, right? So that's the most basic one that we all know about, right? Paper chromatography, it helps to separate compounds based on the polarity, right? So the closer to the origin it is, right, the more polar it is, right? But there's also column chromatography as well, right? And there is also other ways to separate compounds, such as using distillation. You can see in the middle, that's distillation. In the top right, we have extraction, right? That's more of a, as I mentioned, right? It can definitely include something with organic compounds, right? And crystallization, bottom right, recrystallization. So again, right, you might be wondering, I haven't done this in AP Chem, right? I don't know about it. And that's why students, like the test writers here at Georgia Tech, that's why the test writers at GSU, that's why the test writers in other regional, states, and national competitions include these topics, right? Because it helps to separate students out, right? So if you were a test writer, right, would you include everything that is explicitly stated on the rule sheet, or you would test more in-depth concepts, right? So basically, you do want to be familiar with this, especially with regionals and states, because you know that's coming, right? That they do like to test extensions of these topics. It still relates to equilibrium, right? We're still talking about equilibrium. We're still talking about understanding forces, force interactions, but it's just at a higher level, right, with organic compounds. And so we do want to be familiar with these types of compound separations. And there's a lot of resources on this as well, too. Okay. All right. So so far we've talked about common things to know, right? We've talked about right here what we need to know, right? Chemistry basics. We've looked at equilibrium. We've looked at the types of reactions. And then we also have some difficult topics that we took a look at, like redox and compound separation, right? So now let's look at some common questions, right? So these are some questions that were tested before, all the way back, I think, in 2014, right? Because they, as you know, Science Olympiad, they recycle topics, right, year to year. And whenever last time that they had redox and equilibrium and nomenclature, it was all together. It was pretty far back. But again, you can pretty easily find practice problems that have just redox or just equilibrium, too. So let's just first take a look at a question regarding equilibrium, right? So again, the rules manual seems like it's pretty simple, right? It just lists some topics they want you to know. But in reality, you can see that it can be pretty complicated, right? The test questions can be pretty difficult. So this is a question about asking, and let's read it together. The pH value of pure water is 7.0, whereas natural water is relatively acidic. This is caused by dissolution of atmospheric carbon dioxide. In many areas, however, rainwater is more acidic. This has many causes, some of which are natural and some of which derive from human activity. In the atmosphere, sulfur dioxide and nitrogen monoxide are oxidized to sulfur trioxide and hydrogen dioxide, respectively, which react with water to give sulfuric acid and nitric acid. The resulting so-called acid rate has a pH value of around 4.5. Values as low as 1.7 have been reported. So sulfur dioxide is a diprotic acid. Ooh, so we see that, right? Diprotic. That is a little tricky, right? You might not have seen that coming, but pretend this is a states competition, and they'll have that there. In aqueous solution, at 25 degrees Celsius, the acidity constants are as following. Okay. And it also tells you the solubility of SO2 gas at 25 degrees Celsius is 33.9 liters in 1 liter of water at a sulfur dioxide partial pressure of 0.987 atmospheres. The pH of the saturated solution is 0.91. Well, so they throw in that piece of information, which might seem not useful. But we can eventually see that it's really important when we start to answer some of these questions, right? So we can look at first at number 8, right? Calculate the molar concentration of saturated sulfur dioxide solution, right? Ooh, molar concentration, right? So that looks back to what we've talked about with nomenclature, right? That was that major topic that we looked at in the beginning, right? Number 9, right? Calculate the percent of bisulfite ions, right? Number 10, calculate the equilibrium constant, right? And number 11, calculate the pH of this 0.01 molar aqueous solution of sodium sulfite. So for now, I'm unable to work through all of these problems by hand, but next slide, I do have just the basic steps for each of them. And so let's just go back first to look at question 8. So as I mentioned previously, right, we can see that oftentimes with these questions, they will embed a lot of concepts, right, that tie into nomenclature, for example, number 8, right? You may have never expected that they would put this type of equation or this concept in here, but they do, right? But they do. So we see that it is important to go back to talking about nomenclature with multimole conversions, right? With molarity, right? Those are all parts of this problem, right? Stoichiometry, right? That we have gas stoichiometry here, right? It's still stoichiometry, but they're giving it to you in a gas stoichiometry context. So you do want to be familiar with this. Okay. Number 9, right? As I mentioned, counting the percentage of bisulfite ions, right? Well, we had to see that we had to first recognize what is a what are bisulfite ions, right? That's what we're solving for, right? That's what we have to try and solve for. So that's the HSO3 minus, right? So we see that we have to do in this case, right? A kind of like we use our set up our RICE, right? If you have use that method, right? The RICE, right? The reaction, the initial, the change, and the final equation, right? We see that we have that table set up, and we would have to do a calculation to find x, right? X would be represented by those bisulfite ions, right? So we set up this RICE table here, and then we calculate for x, and we find our percent composition, right? Eventually as well, okay? So you see how, in this case, something I do want to note is that in many tests, they will trick you by stating that quadratic equation is needed, right? So you should assume that x is negligible. I know in a lot of AP chemistry, right, calculations, we don't consider x, right, at minus x. We just consider that to be negligible, right? That change in x to be negligible. But sometimes with these competitions, right, they will trick you, right? It might be a tiebreaker question. So you always really want to just do it, since you can use a calculator, right? So you can easily find or solve the quadratic and find your x, and then work from there. Okay. So that's just something to keep in mind. I know because there's going to be a lot of questions that you're going to need to set up these tables for. And then for question 10, right, calculate equilibrium constant for this equilibrium. So we use our K values, right? K2, K1. We use what we know regarding equilibrium, right? You see how in this case we have to know what happens when we flip the equations, right? When we multiply the equation as well, right? What happens to K, right? What happens to K when we do that, right? So if we, for example, multiply the equation by 2, our K, have to multiply K by 2, right? So we have to know all of these things that happen to the equation and how it reflects onto the K value. So in this case, what happens is, as you can kind of see, right, we flip the equation, right? We're flipping in this case, the first equation on the top here, right? So if we flip that equation, you can see now how we have 1 over K1, right? 1 over K1, because whenever we flip the reactants and flip the products, right, that we would have to flip the K value as well. So we have 1 over 1.2 times 10 to the power of negative 2, right? So just stuff like that that you want to be aware of when you're doing equilibrium and we're calculating the equilibrium constant. Again, was this explicitly mentioned on the content guide? No, but it relates to equilibrium, right? And it's all about equilibrium in this year, right? This year it's all about equilibrium and redox. And number 11, calculate the pH, right? You're going to have pH calculations for sure, right? And you see how they set this table up, and they solve for the KB value, so then they eventually can get the pH, right, from there. So you see that knowing your equations are important, right? So you want to go, if you don't know these equations here, you do want to be familiar with them, right? Okay. Right here, bottom left. Okay. All right, so that was just a quick run through. Again, I'll have time to work through it all, but you're welcome to do it by yourself and check your answers because the recordings will be uploaded. So always an option. So second major type of question, we have titrations, right? So with this one here, right, we have this unknown sample titrated against a 0.4 molar NaOH, sodium hydroxide solution. The titration curve is to the right. To the right is collected. Okay, so this is a type some sort of titration curve that if you don't know about it, then you're not going to get the question right? This involves not a monoprotic acid, right, but instead a diprotic acid, right? So we see that in this case, right, it's represented by a weak diprotic acid and a strong base, right? Okay, so you want to be able to recognize what titration you're looking at, right, first, and then, right, numbers 13, 14, and 15, they ask you a lot of questions, right? So for this one, what do you want to know? You for sure want to know that you need to know your equivalence points. You need to know what buffer is, right? You need to know the pKa and how it's related to buffers, right? You need to be aware of what happens if we have a triprotic acid, potentially, right? You might see that as well. Okay. So with these calculations, again, don't have time to go through all of them here, but we see that there are some quick explanations on the side that will help you. And one of the main things with titrations is just thinking about M1V1 equals M2V2, right? That can help you a lot when you're doing these problems. Okay. And so really look into that and how that will help you. Okay. So again, well, you're welcome to go back to the video, go through these problems here, and then check your answers. Okay. Right. And next major question is number 3, right? Stoichiometry. And with stoichiometry, they can do a lot of different types of problems, right? So they can mix what we talked about with reactions with stoichiometry problems, right? So in this case, we see that we have a student preparing a fragment ester in a lab, which presents a pineapple-like odor. In order to conform the molecular formula of her ester, she performs the following 2 experiments, right? So she has 2 experiments that she is performing here. So the first experiment is combustion analysis. Yeah, we've probably seen that before, right? We know about that. We've seen that before, right? With combustion analysis. But experiment 2, mass spectroscopy, right? What is happening here? Well, again, right, this all relates to stoichiometry, right? All relates to when we look at nomenclature, right? It might not be explicitly stated on the formula sheet, but it can still be embedded as part of the test. And especially in the state, you'll see that you have a lot of these stimulus-based questions, right? For sure, in the beginning, you'll have some discrete questions. They'll test you discrete questions, right? But especially with labs and with states and regionals, they will embed these harder questions. And all of these have been relatively more difficult, especially number 1 and number 3. We see that it's really experiment-based. They give you a lot of context. So that is something for you to practice, right? Do practice exams that have been released on the SciOly, which I'll show in a moment. Okay, so number 16, right? Calculate the number of moles of water absorbed, right, by magnesium chlorate. Number 17, calculate the number of moles of carbon dioxide absorbed by sodium hydroxide. Number 18, write a balanced equation representing the net reaction between sodium hydroxide pellets and the carbon dioxide gas. And number 19, determine the empirical formula of the ester. Okay. So with all of this, right, this is a heavy stoichiometry question. And at first, it doesn't seem difficult, right? But when you're looking at all these numbers and looking at the tables and graphs, it can confuse some students, right? It can confuse some students. So looking at and being exposed to this kind of stimulus is important, right? These graphs, these charts, these reactions, right? So let's take a look at the answer. So the first one, number 16, calculate the number of moles of water absorbed by magnesium chlorate. So we see that we have to use our table, right? We see how much magnesium chlorate has been lost, right? How much magnesium chlorate has been lost. And then we calculate that, right, as 0.093 grams of water. And then since we're finding the moles, right, we would just use what we've talked about in the beginning, and hopefully that we know already, right, to find that. And same thing for 17, right? Same thing for 17, but we're trying to find the number of moles of CO2 absorbed by NaOH. Okay. So for number 18, we're trying to write a balanced chemical equation. So again, right, remember that we've gone through a lot of chemical equations, right? We have single replacement, double replacement, synthesis, decomposition. We also have oxidation reduction. We have acid base, precipitation. So again, we want to take a look at knowing how to write chemical equations for those reactions. And in this case, right, it's between NaOH and CO2, right? And a net ionic is not needed. So they do mention that, which is great because I won't need to go back and find it. So I'll save time. So technically, the first one here is acceptable in this case. And make sure that you balance these equations. That's always something that tricks students. Whenever we have redox and whenever you have these equations that you're writing, make sure you balance them. Many students just don't read it. Question. You should always try and balance your equations. Oopsies. Try and balance your equations as it's really helpful. Okay. And then for number 19, determine the empirical formula, right? So we have to utilize our values in number 16 and 17 and apply that right here. And hopefully, right, we know how to find empirical formulas by now as well. It's more of a general chemistry concept, right? Knowing how to find empirical and molecular formulas. But yeah, so the empirical formula in this case is C3H6NO. Okay. So these are the major 3 questions I wanted to include here because they are pretty difficult, right? They're more stimulus-based, higher-level questions because everyone can do the straight questions, but with these questions, they can be a little tricky, and that's why test writers, especially when they want to write a more difficult test, right? They'll include more topics on, right? They'll give you a context, right, of some sort. Right, graph, and it'll be multi-part. Okay, so do keep a lookout on that when you're preparing. Alrighty, So this is some resources, right? SciOly test bank, a lot of practice tests. The practice again that I used, right? So if you like that, you're welcome to take a look at that and the key as well. And then some other resources, right? Just YouTube videos, your chemistry prep books, right? But again, really the best thing is your SciOly test banks. A lot of the resources there. And if you look at the other years, right, although it might not be exactly pairing redox with equilibrium, right, it might be a redox with electrochem, and you can still use that redox portion as practice, right? You can just ignore the electrochem portion. So, again, SciOly recycles questions or recycles topics year to year, and they combine various topics together, right, as we know. So just keep a lookout on those questions. A lot of questions out there. It's really useful. The main thing is to expand beyond, right, the content guide, right? Expand beyond what I gave to you in the beginning of what you should know, right? What you need to know, right? Those are the basics, but they like to expand beyond that. All right. So, does anyone have any questions for me? Any questions regarding topics that you have or other resources? Okay. I think we're good today. All right. Okay. All right. Let me see if there's anything in the chat. Anything in the chat? I think so. Okay, so someone asked if there are any tips for the actual lab portion. Yeah, so especially when you're doing the lab, right? Remember, chemistry lab is a partner event. And so, especially with lab, you do want to get started on that right away. So the lab definitely, if you're working with your partner, you do want to see, right, which one of y'all is more comfortable with doing the lab. Like maybe you've done it before in AP Chem, right? You have more familiarity with it. So definitely, if you want to split up, right, the test, and so one person start on the lab portion, and the other person start on the exam portion, right? That is perfectly fine, right? It just depends how you two like to work together. And with the lab topics, they'll test you, right? A lot of times, as I said, it's going to be a titration, but they can also have something which, right, you have to produce a precipitate, right, as well. So it really depends on the resource that they have. Usually in high schools, if you go to participate in a high school, then they'll usually only do titrations, or they won't even have a lab portion at all. But in universities like GSU, right, Kennesaw, Georgia Tech, right, UGA, they'll usually include something else as well, either separately or with the titration. Yep, you're welcome. Any other questions tonight? Anyone with other questions? Okay. All right. Okay. All right. So if there's no questions, it was nice having everyone here, and just keep a lookout on those practice tests, right? Again, just a lot of practice. It's really important to keep your mind refreshed, and I hope everyone is going to do great at their future Science Olympiad competition. So thank you very much, and I'll see everyone soon.